Good afternoon, all. My name is Brian Sullivan. I'd like to welcome you to another edition of Indoor Ag Conversations. Today we have a great lineup. It's Greenhouse Incorporated, Imagining Energy Efficient Local Food Production in Ontario. So that's the title of our session today. So with that, I want to introduce Rob Lyle, founder and managing director of Greenhouse Incorporated. Dave Lubitz is an associate professor with the School of Engineering, University of Guelph. Hervé Magnus Hugh is the engineer from Ceres Greenhouse Solutions, and Craig Adams is founder of California Lightworks. These are our featured speakers for today. So I'm going to turn it over to them. First, I'm going to let Rob and Dave and Hervé and Craig introduce themselves. Rob, can you give us a minute or so about yourself?
Absolutely. I'm looking at the list of attendees, and it's very impressive. I'm really thanking everybody for taking a moment to learn about our small project just outside of Ottawa in Elmont, Ontario.
Great. Dave, how about you? Can you give us a little bit about yourself?
Definitely. It is good to be speaking to all of you today. I'm coming to you from Guelph, Ontario, the University of Guelph, where I've been an associate professor for about 15 years now. And I do work in renewable energy, environmental fluid mechanics, and practical applications, including greenhouses and energy savings. So very excited to be here today.
Great. Thank you. Hervé, how about yourself?
Yeah, I want to thank you also everyone for joining and for Indoor Ag to organize this. That's a great opportunity. I've been working for Ceres for more than 3 years now as a greenhouse engineer, which means a lot of different things, but I like to do calculations on trying to make greenhouses more energy efficient. And I think that's how I join Rob into his journey to make his greenhouse more efficient.
Wonderful. Craig Adams, how about a little bit about Lightworks? Craig, you're on mute.
Probably hear me better. Yeah. Hi, Craig Adams from California Lightworks. We founded California Lightworks in 2008 in Los Angeles. We are totally dedicated to horticulture. We do all our own design, manufacturing, production, applications, and engineering right here in Los Angeles. We cover a wide variety of crops. We do greenhouse projects. We do high bay indoor projects. We do multi-level vertical farming and everything in between.
Great. Well, thank you, guys. As everyone can see, we have a great lineup today. So we have some planned questions, but again, if you have questions from the audience, please feel free to put them in at the bottom. Sometimes they get answered during the session, but we'll get to them towards the end of our conversation today. But today, the first question we really have is, we want to have a little bit of a storytelling going here. This question is for Hervé and Rob. Maybe Rob, you'll go first on why are we featuring you today? What makes the project relevant, and tell us how you're feeling and how you got started with the project.
Well, for me, the project began with a really crappy romaine that I bought at a grocery store. Sorry, and the romaine had probably traveled, I don't know, 4,000 kilometers by the time it got to me, so it was a little tired. And we had an opportunity to take some property that the family owned just outside of Ottawa. It was well situated to agriculture, actually more to rock quarrying. So we figured we were going to have to try to find something to make this land useful, other than building a shopping center or a parking lot. And so we began our research into greenhouses. We were quite disappointed as we learned just what kind of energy was being taken up. And so we kind of put the greenhouse project aside and said we just really didn't want to do something that was going to cost a lot of money and really not sort of change the world. There's a lot of people out there that are building greenhouses that are just fine. until we came across the Ceres passive solar greenhouse, and that's when the project really took off. We had a chance to look at work with Mark Plinke, the founder of Ceres, and Hervé, and come up with a design which is absolutely fantastic for growing in an extremely difficult climate, which is Ottawa and in Ontario, and in a very energy efficient way, and using some technologies that I think not a lot of people are using. As a matter of fact, the technology we use on the geo exchange, which is the way we put the hot air from the greenhouse into the ground, is only now just being started to be studied, and that's where Dr. Lubitz comes into place. They're climbing all over my greenhouse, putting sensors every place to basically prove the anecdotal aspects of the project. We've really had some great results, but nothing we could really put in a scientific form, and that's where Dr. Lubitz has come in, and we're going to prove that our system is absolutely a fantastic way to grow in a local community.
That's great, and I want to swing over to Hervé first, because the design, the natural processes, what you've mentioned, but then design could come in, and then maybe we'll follow up with Dr. Dave immediately behind that to kind of talk about why that was so important. But Hervé, the design, how did everything go with the design?
I mean, design is the core of our mission series. We are designers and engineers, so that's, and the company started with the idea of trying to grow food everywhere, and that includes like harsh climates like the one in Ottawa, for example. And that's where our greenhouses shine the most. It's when it's cold, you don't have a lot of light in winter, and our design basically keeps this heat from the sun like in the greenhouse, and it can put it below ground when you have like the geothermal exchange system that we call the GAT. And on top of that, we have like solid walls on the east, west, and north side that allows for less conduction heat loss. Sorry for the technical term, but if you are like in a bubble of plastic, you are losing a lot of heat very quickly. We are trying to make like the 3/4 of the bubble solid walls that are insulated and efficient. And that also not only help for the retention of the heat, but also for the light, especially in winter, that when the sun is low in the sky, the light can bounce back from the north wall and on the east and west wall as well. So that's like the design on this case is what we think makes it so efficient is location and the design are just like the perfect combination for Rob.
It's a robust green. It's an extremely robust greenhouse, which is what we need in a northern climate, an Ontario climate. From a snow load perspective, from the ability for this building to last a long time. I mean, this building will last. Well, it'll outlast me, which is, by the way, is not hard to do. It'll outlast, and as I said, and the thing about it is that you in this climate, you never know what the next thing's going to happen. I mean, we've had tornadoes, we've had power outages, we've had all kinds of different things associated with climate change. I guess I don't know if it's climate change, but we just know that it's been an extremely robust building, and I think that's one of the key elements for us when we're growing where we're growing.
Wow, it's so interesting, especially with the seasons. So, Dr. Dave, let's swing over to you. And how do you feel about it? I mean, you must have had your work cut out for you.
Yeah, no, actually, I'm pretty excited about what Rob's doing, what Ceres is doing, and the reason is we've been involved. Speaking of sort of the teams at the university here that I work with, we've been involved in greenhouse-related research for quite a few years. Mainly with sort of the main commercial growers. There's a very large greenhouse industry in Southern Ontario, a very successful, impressive industry, like on their own right. What we're interested in, though, is understanding, going from the each greenhouse, they figure out with a lot of expertise how to grow, how to make that operation efficient, how to produce really good quality. The challenge is if you want to do another one, if you want to grow somewhere else, if you want to change the crops, we want to help facilitate that. So we want to bring sort of a general understanding, and we want to learn and do that. And so the conventional greenhouse industry does really amazing things, but one of their big issues is energy. Here in Ontario, for the conventional greenhouse industry, labor is the second biggest cost. Energy is the second biggest cost, labor is the first. And energy is increasing fast. And not only that, the last number of years, energy has become a very uncertain thing. How do you pencil in what energy is going to cost next year? Anybody want to guess? Anyone want to bet their business on the natural gas price 5 years from now? It's where I'm glad I'm an academic and I don't have to make those decisions and bet my job on it or my business. So we got into it that way. We're trying to save energy. We're trying to help the industry, help growers do things like that. And one of the ways is, okay, there's the conventional ways of growing, but there's the other things you can do. And so like the things Ceres and greenshaus is doing, the extra insulation, the carefully designed building, the thermal air storage in the ground. We've developed models, these computer models, through a lot of work to be able to predict how greenhouses will perform. And we got to a point where we had modeled some of these effects, or at least developed the capability to do it. But whenever you make a model, you got to double check and make sure it actually works. And so we're looking around Ontario, and we needed a way to try it, a way to check it. And that's actually how we got connected with Rob. And then with sort of everybody here was we've heard about this greenhouse near Ottawa. And in Ontario, I will comment, Ottawa is a much harder climate to grow in than where most of the greenhouse industry is in the very southern part of the province, which is zones near Detroit and Buffalo. Ottawa is colder and harsher again with less light. So we got into it because this is a totally unique greenhouse and it's operating, it's functional. Rob's already growing a great crop. Like there's a success there already. So we got into it because we wanted to be able to check our modeling abilities against that. But then the really exciting thing is what they're actually doing, as you learn about it, is really good. This is cutting edge. This is doing something different and doing it potentially ways to really save the energy, to really be more sustainable, which is what we're excited about. And so what we're interested in is first making sure that model works. Then we're going to try and use the model and the insights we get from all those instruments we've put in the greenhouse to try and better understand how to make future greenhouses even better, how to fine tune that earth air storage, how to fine tune the insulation, and how to do that if you change crops, if you change locations. There's a lot of, Canada's a big country, the United States is a big country, huge diversities of climate, huge diversities of light and markets and so forth. And so what we're working towards, and Rob, Ceres, greenshaus is really enabling us to do, is being able to provide that overall insight and maybe that guidance to really sort of improve the sustainability and really save energy by doing things a bit different. That's what we're excited about.
It's amazing, what you've presented here so far. So, and with that, I'd like to pull over to Craig, because Craig, it looks like they set an incredible table here of challenges for you, and now the lighting has to come in. So, I'm dying to hear how you address this with different types of energy and lights are different at different times of the year. So, take it away. How did you feel about the project?
No, well, first of all, we love working with growers who are trying to innovate and trying to improve their business model, especially through their infrastructure. So it's been great working with Rob. He's been willing to try a lot of new technologies. We work closely with Ceres on a number of their greenhouse projects. And it's a fantastic model because it really combines the best of indoor with greenhouse. So you have a closed sealed environment much better energy management, much better management of all the environmental concerns. Also, Guelph University has been great. We've done several projects with them in cannabis. They've got probably one of the most extensive cannabis research facilities and wonderful test greenhouse out there. So it's great to work with these people. I'll run, lighting is a very complicated subject. I'm going to run through it just very briefly, how we consider what type of lighting and how does it laid out, what kind of systems do you put in. So we have lighting for both indoor and greenhouse. Obviously, greenhouse, it's your supplemental light. You're really trying to balance what you have from the sun. Indoor, it's your primary light. So you're providing 100% of the light. So that makes a much different approach. So also in a greenhouse, you have either photosynthesis, in other words, you're adding light to get more photosynthesis during the year. You also have cases where you have to extend the daylight, which is photoperiod. If you can extend the daylight if the sun, the days are too short. So you have to take all of these things in consideration. Also, heat generation. Most people in indoor are concerned about not putting too much heat in the grow space. Obviously, LEDs are perfect for that. In some cases, like in the north of Canada, they rely on the lights partially for heat in the winter. So it's an efficient dual usage rather than adding supplemental heating. You can use the lights to offset some of the heating requirabilities. Then the final consideration is working visibility. It's red and blue are the peak light spectrum for photosynthesis, but they're very hard to work under. You need some white light, especially if you have only the lights on for a short day. So those are the types of considerations, what type of lighting and the difference from indoor to greenhouse. We make two basic types of fixtures. One is a linear fixture. So these are long, quite powerful. These are good in the greenhouse because it reduces the shadow effect. You can put them on an existing truss or on unistrut. So you want to block the sun to the least degree possible. Indoor, that's less of a factor. High bay, you want very concentrated lights and a small footprint. And then we have vertical or multi-level, where you're using a very wide spread out fixture, trying to get very close to the plants without undue burning. Obviously, so what we're talking about here is mostly greenhouse. So when we first we started talking about this project with Rob, we basically have to gather all the basic information like the floor plan, the ceiling height, whether he's using fixed benches or rolling benches. All those things will adjust where we want the light, how it's laid out. We also look at reflectivity. Reflectivity on the walls, the floors, and the ceiling plays a big part, which is all computer modeled in a light plan. Also, the light transmission through the greenhouse material is really, really important, where you get much more light with, let's say, a glass greenhouse than you will on an old faded plastic. That's what Ceres has done a great job, especially the way they orient the positioning of the greenhouse to the sun. So it's a huge advantage of conserving as much of the sunlight as possible. So obviously one of the first question is, how much light do you need? And every crop has a different light level requirement. You have, on the high end, you have things like cannabis and tomatoes, which is the highest light demanding crops. Then you get into lettuce and leafy greens and herbs, which are kind of at the low end of the spectrum. This is all measured in PPFD, that's the amount of light per square meter. And it also, you have to measure the DLI. The DLI is the daily light integral. That gives you the average level of sunlight you'll have at any location in the world on an average per month basis. So in Rob's cases, he's really in a very cold, low light area of the world that, it's drastically cut down the amount of time you can grow just under natural light. So you have to add much more supplemental light if he's going to maintain that yield across the whole season. So once we establish that light level and we know the DLI, we can say, all right, he needs an average PPF level. Those range from about a low of, let's say, 100 up to a high of about 1,500. So if we say in Rob's case, well, we'd like to maintain 400 across the whole year, we need to guarantee him he'll have 400 micromoles in the depth of winter. So that kind of determines how many fixtures you need, what's the level of intensity. then, well, the beauty of Ceres greenhouse, we can mount our lights directly on their existing trusses. So it's creating no additional shadow effect. So once again, it's a very efficient use of not blocking the sun and getting the maximum out of the LED lighting. A very important consideration that we've always followed is spectrum. A lot of people don't think that much about spectrum. Most of the bigger greenhouse lighting suppliers will offer a range of different spectrum for different crops. They'll have one that's high red, one that's higher in blue, one that has higher white levels. And these are all specific to various crops. Our approach has been to use variable spectrum. So all our lights, you can vary that red, blue, and white spectrum. Each channel you can vary from 0 to 100%. So that allows you to adjust the intensity and also to get the most possible efficient spectrum. Like I say, the reds and blues really drive photosynthesis. That's where we want to put most of the power. But whether you use heavy red or heavy blue will actually change how the plant grows. So depending on the crop, you can vary that, where flower and fruiting crops generally need a higher level of red, where leafy greens and herbs and things like that, the blue is more important. But we give growers the ability to kind of dial that in a dynamic process. We also have played with additional spectrum such as far red. You can add supplemental far red, which gives you larger yield, especially in leafy greens. We work a lot with UVA and UVB. In fact, we did a study on UVB with Guelph University, UVB and its effect on cannabis. Obviously, infrared is also a consideration, where some of the older lights like HPS, infrared temperature on the leaf will govern nutrient and water uptake. So it's an important factor. With LEDs, you have less infrared impact directly on the leaves. So you need to compensate that either with the heating, so you can combine that in your environmental controls. As far as controls, it's another key area we've always focused on, and Ceres has done a great job with this. So, I mean, as far as the lighting in a greenhouse or indoor for that matter, you can use a basic timer. Indoor, it's pretty easy. You turn it on, you turn it off. Greenhouse, it's not so obvious because you only want it to go on when your light level drops below a certain level. Otherwise, you don't need them. You'd rather not turn them on to conserve energy. So we offer an automatic photo sensor, which will actually adjust the lights up and down, where you preset the minimum light levels. That will just run automatically. But we also have a touchscreen controllers you can do that with, a wireless. And we also can connect to any third-party controllers. And that's, in this case, we work with Ceres. They have a very sophisticated environmental control system, which can take advantage of all the function of our lights in conjunction with humidity, with temperature, with whatever other considerations you have. And the last point I want to make is obviously energy efficiency. That's the reason we got into this in the first place, because LEDs are just so much more efficient than the traditional fluorescent or HID lights, which had been used in the past. It's up to the point where it's at least double the amount of light for the same amount of power versus HPS or metal halide, which used to be the most efficient. So you get at least twice the amount of light on the same energy. You get half the heat with that same amount of light. So there is no comparison anymore. Also, if you're using advanced controls, especially photo sensor or something that ties the light to the actual sunlight available, you end up getting the maximum light coverage for your plants without overshooting and wasting energy. And then finally, focusing on the right spectrum will greatly increase the efficiency of your lighting. So you'll get more growth, more yield, for less energy. And obviously lighting is a complicated subject, and I'm available for any questions later.
Yeah, that's great. It's quite a project. And so I want to swing back to Rob and say, Rob, you had some family land and you called up 3 buddies and decided to build this thing. That sounds like much of an oversimplification. There must have been a plan or something there. You had to come up with a budget and things. So, how did that come about? Or was there some surprises in there as well that you went, uh-oh, what's this? And a lot of times the surprise is an education and helps you do things better.
Well, first of all, I feel actually blessed to be surrounded by three very, very smart people. They're all scientists. I would be considered a layman, but what appealed to me about this was we took it down to some very simple principles. We wanted to make sure that we had a greenhouse that was efficient, and in this case, you've heard all the noise. How we're combining the use of the heat we get from the lights and collecting the sun and the solar orientation and all those wonderful things that we've landed on, but they all come from some very simple principles. Again, I'm more the 60,000 mile up guy than our scientists here, but so one of the biggest things was we had to make sure we kind of looked around at what was going on in the industry. And what we found when we did the research is you have people who are very dedicated to their style of greenhouse, and we found the community wasn't really open to a lot of different ideas because they didn't really need to. Everything was working fine. We had decent oil prices, interest rates are great, supply chain seemed to be working. But fast forward 3 years from now, and look at the mess that we're in with respect to having to try and have stuff shipped all over the place. We're draining California lakes. We're doing all those sorts of things. And so we said, okay, well, how do you solve these issues? We're just a small town. We're just a little guy here. We want to look at some common sense solutions. And not just the greenhouse, as I said, let's take a look around. We only sell our product 30 kilometers from the greenhouse. And I just came back from the greenhouse a couple of hours ago from filling some more orders. We sell everything we make within that 30 kilometers. We could sell twice, 3 times, 4 times as much. And when the produce manager sends me a text on a Saturday night, he's got his 10 cases of lettuce Sunday morning to get his stuff. So everything is instantaneous. Everything it's so flexible. And so what got us going was, how do we simplify this thing? This can't be this isn't rocket science. All the engineering is there, but what we're missing is the local. Everybody talks about local. In Ontario, they talk about local, but do you realize how wide Ontario is? It's a couple thousand kilometers. So, something that's produced in Thunder Bay, Ontario could be considered local for, Ottawa, Ontario, which is ridiculous because it's farther, it's like driving to North Carolina, and you wouldn't call Ottawa, North Carolina local. So again, it was okay. So how are we going to service the local area? And what makes sense? Well, McDonald's doesn't have a McDonald's to serve all of North Carolina. McDonald's has a greenhouse or as a store on every corner, and they make sure that they're producing for that area. So every customer in McDonald's is really a local customer. And we wanted to do the same thing in greenhouses, where we could create greenhouses which were producing a sufficient amount for the community they're in. So it doesn't make sense to build, in a community of 5,000 people, it doesn't make sense to build, a 10,000, 15,000 square foot greenhouse. It just doesn't make any sense. So how do you fix that? Well, you create these beautiful high yield greenhouses, which will deliver the product 30 kilometers from the greenhouse. I don't know what that is in miles. I've forgotten all that stuff. But, with a carbon footprint, by the way, and I know this has been some of the literature, but we do a delivery to our local big box grocery store in Elmont, 3.3 kilometers from us. We put 0.7 of a kilogram of CO2 into the air. There's product on the shelves in that same greenhouse that the truck that brought those products puts about 3,000 to 4,000 kilograms of CO2 in the air. The environment, the atmosphere doesn't know how many lettuces were sitting on a semi-trailer, 54-foot semi-trailer going from Coaldale, Alberta to Elmont, Ontario. All it knows is that 3,400 or whatever the number is, kilograms of CO2 went into the air. The product is picked and on the shelf within an hour or 2, 3 hours, 4 hours at the most. We put 0 carbon footprint in. The price is reasonable because we don't have any, the distribution cost is almost nil, and the product is fresh. It hasn't lost. As Ceres marketing stuff tells, you know, it hasn't lost 45% of its nutrient value. You know, it hasn't traveled, you know, 1,500 miles, whatever it isn't, you know, all those things. And so if you could start, I mean, our greenhouses won't defeat big greenhouse, but it will certainly take the pressure. It takes the pressure off of those large scale greenhouses that need, say for Niagara Peninsula, that need to service Toronto, need to service, you know, those areas. But as far as Almonte, Ontario, or even Ottawa, I mean, we are, you know, we're 15 minutes from Ottawa, Ontario, which is a population of 1 million people. We you know, we could send lettuce to each one of the grocery stores in there under 40 kilometers with zero, you know, so it's just, and we're building a building that, yes, when you first put it up, it was a little more expensive, but it's robust. It's very suited to the community and where we're growing. You know, it's a perfect dynamic greenhouse to sort of to take some pressure off, take some relief off, create some food security for the locals. And by the way, we're growing lettuce. We only grow lettuce because it was our test crop for the greenhouse. I mean, if you look at what's happening in the Netherlands and the systems that are being built, we could produce any crop just about in our greenhouse. You know, multiple greenhouses, a couple of greenhouses. We locate a greenhouse on the other side of Ottawa or other different places. So as long as we hit that, you know, 30-kilometer circle, and by the way, you can sell a ton of lettuce in 30 kilometers. You know, why not? And so this is what excites me about this project is that it's you know, container growers, and I see grocers on the list are excellent for certain areas. Large scale greenhouses are excellent for certain areas, and our type of greenhouse fits a market which is very robust and meets, you know, all of my considerations, which are low carbon footprint, easy, you know, easy to make a profit, easy to run, you know, environmentally friendly, sustainable. Like you just, you know, it ticks all the boxes.
So it seemed like you found a need and you filled it in your arena. So that's unbelievable. And we have about 10 minutes before we get to questions and things. So Hervé, I want to swing over to you because I read the article in Greenhouse Canada magazine, and the thing that was striking me was the you know, geo and solar you were using on it. So there must have been a challenge or two in there when you got the reins. So is there something specific you could tell us about that was good or challenged or surprised you and then worked out well?
I mean, yes, of course, and there are like many challenges along the road, and Rob can talk about that because he didn't start like with all the equipment that he has in his greenhouse right now. He started with trying with using minimal equipment, almost no artificial lighting at the beginning, for example, and try to test the limit of this capacity of the greenhouse at the time. And months by months, working very closely together, like I don't want to count how many hours I spent working with Rob, but that was a pleasure, and that's still a pleasure. And we started to improve the greenhouse every month until like the point that now is to the point of being like a commercial growers. And now we are again reaching the next step because we are designers of greenhouses. I work behind my computer. I don't have the chance to go to Rob's greenhouse every day. And now we can reach the next step, which is working with university and academic people that can confirm what we think is best for the greenhouse. Because sometimes we think we know, but maybe we could learn. We can always learn, right? And now we have this amazing opportunity to have like years of PhD and really smart people to actually have sensors in the greenhouse telling us exactly the amount of light, and how the geothermal is behaving, how the passive solar design is behaving, what's the efficiency of that? Because we think a lot of good things about our greenhouses. That's why we still work for this, and we are sure that it's a lot more efficient than other greenhouses. Just as a rough figure, for Rob's case, I think it's I would say around, I don't remember exactly the bills, Rob, but I would say around $3,000 of propane for heating an entire year, against will be 12 to 13,000 for a greenhouse that is more traditional, meaning no insulated walls. So just like weigh the pros and cons. It's huge, the amount of money that you put in that and the CO2 footprint that you also have and that you reduce using Ceres is huge. But you were bringing the geothermal aspect of it, and that makes me think about something that is really important right now, is the control, how you want to control your greenhouse. Because something that needs to be really emphasized for growers is that thinking cheap decisions is not sometimes the best way to go. Because if you think cheap, yes, I'm on the budget, I cannot afford this controller that is maybe a few $1,000s more, but the capacities of the controller might not be able to keep all the equipment working together in an holistic way. And that's what we are trying to achieve with Rob's greenhouse, using the geothermal, using the lights, using the ventilation. And for example, we try to use a refrigerant dehumidifier, a standalone dehumidifier. And we noticed that sometimes it's more worth to use a combination of heating and ventilation rather than using the dehumidifier. These kind of things, and we are very grateful to work with Rob because he's someone that is open to any suggestions and he's way smarter than he says he is. He understands a lot of the technical things, and that's great because that helps us. And at the end, when I'm calling Rob and I'm telling, hey, Rob, I think you should do this, and he's telling me, yes, but look, my lettuce is a little bit too small right now. Like, let's bump the light a little bit percentage-wise. And I was looking at the weather files and all this theory stuff, and I was like, Rob, you should do this. But no, he's in a real world. And so that's really grateful to have this collaboration of like the theory and the real world, the reality. So I don't know if that answers your question.
No, it does. It sounds like flexibility is the word I'm taking from it, because if you have to, if you have hard and fast rules, sometimes that doesn't work. You're going to have to make a change. So I'm going to swing over to Dr. Dave now, and I have the same question. Was there a specific challenge or something here that surprised you in a good way or a bad way?
Yeah. Actually, I was surprised in a good way just working on this project. Rob mentioned we've crawled all over his greenhouse and strung wires and sensors everywhere. We really probably messed up the Bauhaus aesthetic a little bit. Don't look at the details of our wiring jobs. The rest of it's beautiful. But that openness, right? That interest in more than just sort of get results, maximize profit, really does ripple through sort of everything everyone's doing. Like that openness to trying things. And so what we're really excited about is we've got an operating greenhouse here. It's different, but it works. It already works. It's proven. And what we're really excited to find out is how optimized is it? And how much can we tune it, so to speak? Like how much more sort of potential is there to save even more energy by making some adjustments, by doing things? And that's where we're going to bring the computer model in. Our computer model will allow us to simulate thousands of runs of the greenhouse with things different. You just can't do that in real life. And then
so again, it sounds like flexibility is really it. That Rob as the leader is kind of really giving the reins over to you guys and let you kind of play with it if you'd like. So I'm going to ask Craig.
That trust was huge.
So Craig, I'm going to swing over to you. What was your big surprise here, and how did it work out for you?
No, it's been a great project. What's interesting to us, you just said flexibility, because we want to give growers the ability, if they switch to different crops, the lights will adjust to whatever they're doing. So we work with some other greenhouses in Canada where they'll do tomatoes in the summer, but in the winter they don't have enough light to grow tomatoes, so they'll switch to lettuce, let's say. But now you need a lighting system that can kind of accommodate both crops to give the grower flexibility rather than being fixed into a particular, set lighting that only works for a particular crop. But the nice thing about the Ceres greenhouse, you have a lot more environmental control than in a traditional greenhouse, which relies heavily on opening vents and using fresh air ventilation, which creates huge humidity problems and temperature control problems. So this is a unique environment where you kind of get the benefits of indoor, that controllability of everything, but the low cost production, in a greenhouse. So it's quite exciting. And when you start talking about measuring, putting sensors everywhere, that is so important because we don't understand like what happens to the humidity right after you water the plants. What happens to the humidity and temperature when you turn off the lights? Things like this create huge shock to the plant's environment. If we can measure it, we can understand how to better transition, from fertigation, from lights on, lights off, combining things to adjust for temperature and humidity variations. So it's exciting.
Again, all of this is really exciting. I mean, just to, from a piece of land to production and delivery is just unbelievable. So we're just about the time to start asking questions, and there's a couple in the queue. Folks, if you'd like to add some more questions in the queue, please feel free. But there is some anonymous folks are asking, what are the pros and cons of greenhouse versus indoor? Is there any kind of examples that you can give on there? So let's go quickly around the horn here and start with Rob. Rob.
Well, I mean, if you're building inside of a building, the obvious thing that you don't have is the sun. There's a school of thought that says, I mean, I don't know about you, but if someone sticks me in a room and throws a light on me, I don't feel as good about myself as if I'm sitting under the sun. So I have a little biased opinion there. I think growing in a building is it's another way to do it, but it's not part of my philosophy. So.
If I may, I think there is space for any type of grow, indoor, vertical farming, greenhouses, huge greenhouses, outdoor. There is a space for everything, all of this, but you cannot put each of them in any location that is can duplicate it this way. It has to make sense with your environment. And I think vertical farming is something that is great, for example, for very dense cities. And greenhouses are great systems for something that is more suburbs and for deserving more local areas like Rob does. And outdoor, obviously, in the summer, that's probably what is the most sustainable, even if in terms of water, it's very far from being sustainable, but don't want to expand too far on that. That's my opinion.
Cool. Hi, Dr. Dave, what do you think?
It's interesting. I don't have an answer to it, but I'll say it's one of the questions we're really interested in. This actually got posed to us at a conference. It was one of those ones that the light bulb goes on. Like that phrased it perfectly. In a lot of Canada, there's places in Canada with even less light, right? Especially in winter and even colder outside. At what point does it make sense to switch from the greenhouse where you're bringing in all that natural light, which in a sense is free, at least the incoming light, versus switching to an enclosed model where you provide all the light? And it's going to depend on that climate. It's going to depend on that crop. It's going to depend on so many things. But it's one of the things we're really interested in mapping out, is sort of where that divide is as you change crops and places and situations.
And what is the scale also of the project? That's something important. Like if you want to build like a multi-million-dollar vertical farm that is hectares big, or if you want to go towards smaller sizes, that decides a lot also, because labor and energy costs are not the same. I mean, you need to take that into account.
Great. Okay, we're still getting some more questions. How about you, Craig? What are your thoughts on this?
Well, we have a lot of experience with cannabis, and I'd say about half of it's greenhouse and half of it's indoor. The reality is it's all about cost. A good indoor grower, his cost per pound is, let's say, $300 to $600. That same crop in a greenhouse, it's $100 to $300, just because the energy cost lighting cost is so essential, and the amount of electricity for lighting is so big that you have a natural advantage anytime you can use the sun from a cost per pound basis, which when the price goes down, which is currently the case, those high cost producers are going to struggle. Now, this may not be true for low light crops, leafy greens, lettuce. which I think the comparison is a lot closer, where you get better efficiencies because there's less energy.
Great. Rob, we're getting some questions in here, and some folks are starting to ask about budget. Were you on budget? Usually projects are over budget. Was it a lot or a little bit? If you wanted to comment on that, on how you felt the project went financially overall on the construction.
Financial suicide, basically. Kidding. No, you have to balance the finance between what some of your personal objectives are. And yes, we spent probably more money with the first project, but the whole idea with this was a prototype to understand just, what we can do. So the first one, what's the budget? I think we probably spent about, I don't know, $500,000, but that means carving it out of the woods, creating the landscaping, doing the different things, bringing things in from the US. So the first one, what's the budget? Well, I mean, we didn't really have a budget, but we do now because I understand. I mean, I didn't know anything about this business 3 years ago, 3.5, 4 years ago, but I do know money. And so we needed to have the freedom. So I self-finance it. We need to have the freedom of not having someone tell us what to do. But we also had the freedom of having very smart people. So from a money perspective, yeah, could we build it cheaper? Yes, absolutely, we could build it for cheaper, and we can build it so that it makes sense for the local, for shipping local. So, I would say the biggest fear people have is losing money, and it's a big fear, but sometimes you just have to go and do things, and was fortunate in my life that I had the opportunity to have had a bit of funds tucked aside. So we were able to do things. And so it's still farming. At the end of the day, this is still farming. I'm working my ass off. I'm working at the greenhouse every day. This is not, if you think this is your, you've made your money in high tech and you're going to run the vineyard. This ain't it. This is farming. This is cruel. Nature can be cruel. You have to have the mental fortitude to deal with stuff like that. And you have to have even greater mental fortitude to deal with engineers. So, no, I'm just kidding. The engineers, they are the only reason it keeps. So yeah. So as far as money goes, and as I said, we purposely kept the government out of it. We purposely kept a lot of people out of it so that we could make decisions, good, bad, or indifferent. I probably made $150,000 worth of mistakes, but that's the only time I'm going to make them. So, so yeah, this was certainly a pioneering project. I mean, this is how I would describe it, as a pioneering project.
Well, I'm going to stay with you, Rob, on that. And then this next question, I think we'll roll into the other three guys here for a second. So, because the budget is really someone who's controlling it and owning it. So that's your position. But the products that you pick, how does that impact? Because I know that's going to impact design, it's going to impact lighting, it's going to impact temperatures and things all the way across the board. And you may have selected one now. You mentioned earlier that it's because that's what you were doing. Is there with that, why did you select that? And is there a change or what's coming in the future, another facility or anything like that? So we can roll that across to all the gentlemen.
So the greenhouse itself meets all the, it's a phenomenal facility. It'll grow tomatoes, it'll grow just about anything. It'll grow hemp clones. I mean, I think there's somebody in Colorado that makes 5 times the money I make a year just selling hemp clones. So, I mean, the greenhouse itself is extremely versatile. It comes down to, hey, what crops what interests you as a grower? What crops, when it goes out that door, what makes you feel good about, what people are saying about your product? And the greenhouse will do this. This greenhouse in my environment does it. It'll do it anywhere in Ontario. It'll actually do it anywhere in Canada, upstate New York. I don't know any of those places. But at the end of the day, it's kind of, if you're going to be a farmer and you're going to work that hard, what crop makes you feel, what excites you the most? And so that's where the flexibility comes in. We talk about flexibility. Yeah, you can, if you just want to grow, microgreens you want to be the microgreen giant in Biloxi, Mississippi. Like, hey, there you go. You got your greenhouse. I mean, as a person, you as a business person makes a choice as to what you want to produce and sell. So,
Wow.
hey, knock yourself out.
So,
And we have customers growing everything: microgreens, lettuce, basil, tomatoes, cannabis, everything. Like the greenhouse can work for everything.
but that does impact the bill, though. Does it or does it not?
No,
I mean,
it's the equipment. No, because
it-
Craig can build lights for whatever crop it is, so that doesn't change. The light's still there. If you choose to go hydroponic, NFT, we've done that. But I mean, there's all kinds of things. There's not really a lot that has to change in the greenhouse because you're still going to have controllers. You're just going to set them differently. So there's not a lot that has.
The amount of light, Rob, the amount of light if you're growing tomatoes in winter compared to lettuce will be, your electricity bill will be higher, like quite higher, I would assume. And you also ideally want to keep the greenhouse a little bit warmer, but because the greenhouse is efficient, that's not where you will lose the most money, I think. But lighting will be, you will see the difference in electricity bills, I think. But it will still work very efficiently, more efficiently than other greenhouses.
Well, I mean, you got to price your product to sell based on your costs, right? So, I mean, if
Sorry?
you got to price your product to sell on your costs. If you've chosen to grow tomatoes, well, you know that that's going to be more expensive, and you know that your clients are going to have to pay more. I mean, I think the cheap food are disappearing. How you save money is not transporting it all over the place.
Craig, how about you? How does it impact you when you do it? Do you light varies? You were mentioning it earlier, but does it matter to you, or do you have to?
See, one thing you should show some photos of the greenhouse while I'm talking. The light budget is going to shift dramatically based on the crop. It's dramatic. Microgreens and lettuce and leafy greens, it's about 100 to 200 micromoles, at PPFD level. Tomatoes, you go up to 800. Cannabis, it goes up to 1,000 or 1,200. So it's dramatically different. You can see the lights here. That's kind of a moderate light level, about 400. So 400 micromoles will allow a pretty wide range of different crops you could grow in there. It's good. You could do tomatoes in the summer with this amount of light, probably not in the winter. You'd probably have to beef it up or grow other things in the winter, but it definitely gets more expensive. Your tomatoes will take 3 times as much light as lettuce will. And that's for the fixtures, the installation, and your electric bills.
Wow. Dr. Dave, comments, please.
It's interesting because every crop is different, but at the same time, I'm coming at this from a sort of the mechanical engineering energy perspective. If the structure has been built from the start to be energy efficient, to have sufficient ventilation, to have sufficient lighting capacity, you should be able to, with care, grow all kinds of different things in it. And it's probably it seems to me to be a good strategy to do that, as opposed to, you can probably save a bit by optimizing a greenhouse or a particular growing setup for one particular crop. You save a bit on the lights, you save a bit on the configuration and so forth. But the flexibility you get by being able to grow a wide range of things is probably an asset. Now, this is an academic talking about sort of business decisions, so take that with a grain of salt. But.
The questions are pouring in right now too, from Canada, Jamaica, around the world. So before we close, because we have about 5 minutes left, I want to ask what's next. Is there another one in the future, or is there 1, 2, 5? Is there a plan to go larger, Rob?
So if there are any of your registered guests that have a lot of money, and I see a couple of great financing people, we'd be more than happy to chat. I mean, the goal, I'm like Steve Jobs. I want to be the Steve Jobs of small greenhouses. So, Mike Ballmer or Steve Ballmer said Steve Jobs would never have his. So my greenhouse is the iPhone of greenhouses. So we want to build this into pretty much a bigger company than Apple. So to do that, we need, and I'm just being facetious, but at the end of the day, no, we're trying to, we want to find like-minded investors and like-minded people who love this concept and start working together to build these things. And this is not something that I alone can do. I mean, I only have a certain amount of resources, but we've proven this concept. I mean, this was our prototype. It works. So the next steps are to find people and actually to find growers. Like I'm doing the growing, and quite frankly, we could probably double our production just based on having a professional grower. There's just so many different things that can happen when you start getting some funding that can take us to the next level. And that's kind of where our focus is next, is how do we now translate all of this good information and data we've collected. I mean, between Hervé and Ceres and the University of Guelph, we've got so much data, we don't know what to do with it. We are very data driven on the sales and production of our plants and those sorts of things. So we've got all that. So really it's a question of finding the people who want to join us in the journey to make stuff like this happen. And that's why a forum like this is very good, because we can get out, get a little bit of exposure and let people know that there are different ways to do these things. And we think we're one of the key drivers going into the future.
Sounds like you mentioned McDonald's earlier. Maybe sounds like you should be franchising soon. So,
well, exactly. I mean, and you know what's interesting? You laugh about that, but one of the things that's really we found is local people. If you're going to have someone in the local area, they love that person. You become sort of the little star of the area. You're known as the lettuce guy or the whatever, and you do really develop a brand locally. And so, if we're going to run these, you really do need, someone in Témiscamingue, Quebec, who's popular and is, respected. You may even have people that are already growing different types of crops that have a reputation. Well, to bring those people, so it gives that local flair, because people like to know where their food, they like to see where their food's grown. They like to know who the owners are. And that's one of the intriguing things about local. And quite frankly, everywhere you live is local. So.
Great. So with that, we have about 1 minute left. So I'd just like to have everybody just say one closing remark. Rob, will start with you, and then we'll go to Hervé. And one very quick remark before we close, because we're coming up on 3.
Well, help join a revolution.
There you go. Hervé, how about you?
Just so many questions that I could not have answered in the chat. Please feel free to reach out to my email. I think it was shown somewhere. And thank you everyone for the invitation, the opportunity to have this talk. Thank you, Rob, for being the star of the show today.
Dr. Dave?
Yeah, I've gotten into this area as research, and I find it really exciting. There is so much going on, and there is so much to learn, and so much to do.
Craig, how about you?
Well, we're just excited to work with Ceres Greenhouse. They've done a lot of innovation. You can put them in extremely cold climates, high snow levels, hot climates. Most other greenhouses are just your basic structure and plastic. We really enjoy working with them.
Great. Well, I'd like to thank everybody. First, our panelists here. It's a great project, Rob, and your team is unbelievable. I want to mention to everybody, we didn't get to all the questions here, but this is being recorded, and you will be able to go to our website. And the opening shot is of these gentlemen here with a link to their LinkedIn pages. So if you have specific questions, again, I know we didn't get to some of them. Some of them were very direct for their own personal usage and things. So you might want to go back on and take a look at that. So I'd really like to thank all of our guests here, and look forward to you and let you know that you will be getting a survey as well. If you would answer the surveys and come back, that'll help us deliver more content to you and conversations. So I'd like to thank everybody who was here. We look forward to seeing you at the CEA Summit in October and Indoor Ag in Las Vegas coming up in February. But other than that, again, thanks to our panelists, and we look forward to seeing you on the next Indoor Ag Conversations. Thank you, guys. Thank you, everything.
Thank you.
All right.
Thank you all.
Thanks all. Sure. Bye now.